In this video, we're going to be multiplying radicals by using the distributive property and FOIL. So in this first example, we have the square root of 6, and it's going to be times by the quantity, the square root of 3 plus the square root of 2. So here we're going to use the distributive property and distribute that square root of 6 into both of these terms in the inside. So to write it out, we'll have the square root of 6 times the square root of 3 plus the square root of 6 times the square root of 2. Well, 6 here is going to be 2 times 3 along with the 3 that's already there. So it'll be 2 times 3 times 3 when we put all of these together under one radicand. Plus, and then we said that the 6 was 2 times 3. So I'll put the 2 and this 2 and the 3 in that order, again from least to greatest. Easier to group things up that way. So this one has a pair of 3's that will come out, and this one has a pair of 2's that will come out. So our final answer for this one will end up being 3 times the square root of 2 plus 2 times the square root of 3. This example is going to use the distributive property once again to take this 3 radical 10 and distribute it into this quantity, 2 times the radical of 15 minus 5 times the radical of 14. So again, we have this 3 times the square root of 10 times 2 times the square root of 15 minus 3 times the square root of 10 times 5 times the square root of 14. Okay, so in both cases we're going to multiply the coefficients out front and get 6 times the square root of 10 times 15 minus, and then the coefficients, 3 times 5 will be 15 times the square root of 10 times 14 when we multiply both of these together. So this 10 right here will be 2 times 5. The 15 will be 3 times 5. This 10 will be 2 times 5. And this 14 will be 2 times 7. So I can rewrite all of these radicals. And this first one will be 2, 3, 5, 5. So 2 times 3 times 5 times 5. Again, because it's easiest to put them in ascending order from least to greatest. And then we have minus 15, and this radical will be 2, 2, 5, 7. So 2 times 2 times 5 times 7. At this point, we can see what pairs up. Looks like we have a pair of 5's here and a pair of 2's here. So these 5's will come out and these 2's will come out. To go with the 6 that's already out there, we'll put this 5. And on the inside, we have this 2 and the 3 that's left over, so we'll put 6. And to go with this 15, we have this 2, and on the inside we have 5 times 7 left over, which would be 35. So to finish up here, 6 times 5 will be 30 times the square root of 6 minus, and then 15 times 2 will be 30 times the square root of 35. And that's as far as we can go with that, because even though both of these are 30's, that's just the coefficient. The true thing about these like terms is that in order to be like radical terms to go together, these radicands and the index have to be the same. They're both square roots, but this is the square root of 6, and this is the square root of 35, so this is all the more simplified we can make it. For this problem, we're going to be using FOIL because we have this quantity, 2 plus the square root of 3, times this quantity, 7 plus the square root of 3. So FOIL tells us that we're going to take this 2 and distribute him to both of these terms, and then take this radical 3 and distribute it to both of those terms. So when we do that, 2 times 7 will be 14. 2 times the square root of 3 will be plus 2 times the square root of 3. Square root of 3 times 7 will be plus 7 times the square root of 3. And then the square root of 3 times the square root of 3. I'm going to write it this way, because when you multiply these two radicals, it's going to be 3 times 3 on the inside. And then for this time, we see that we have a pair of 3's, so it'll come out. So really, it's going to be 14 plus 2 radical 3 plus 7 radical 3 plus 3. Because the square root of this, 3 times 3, the 3's pair up and just make a real 3. And there's nothing left out on the inside, so the radical goes away. So now we see, do we have some like terms? Well, here's an integer and here's an integer. So 14 plus 3 will make 17. And it looks like here's other like terms because both of these are square roots of 3. 2 square roots of 3 and 7 square roots of 3. Since we're adding these, it'll be 2 plus 7 will be 9, and then square roots of 3. And that is as simplified as that will become. In this example, we're going to be using FOIL again to multiply the radical 6 minus radical 2 times radical 3 plus radical 2. So when we distribute this radical 6 through both of those terms, and then this negative radical 2 to both of those terms, we'll see what we have and put together hopefully any like terms that we have. So the first one will be the square root of 6 times the square root of 3. So that'll be the square root of 6 times 3. And then the square root of 6 and the square root of 2 will be the square root of 6 times 2. And again, this is positive. So we're going to distribute this negative through, so it'll be minus the square root of 2 times 3. So 2 times 3. And then a minus times a plus there makes another minus. And then square root of 2 and square root of 2 will be 2 times 2. Okay, so these 6's here will actually reduce down to 2 and 3 for the prime factorization. So I'll write it that way. So this first one will really be 2, 3, 3. So I'll say 2 times 3 times 3 plus, the second one will be 2, 2, 3. So 2 times 2 times 3. Then we have minus, and 2 and 3, they don't have anything to pair up with, so they're just going to stay there. So I'm going to multiply them together to get 6. And here the 2 and the 2, they'll pair up and come out to make just a 2. And these subtraction signs just come along, just like you do when you're foiling normal things like polynomials. Okay, so let's look back here. We have a pair of 3's in this one, a pair of 2's in this one. So it looks like this is going to become 3 radical 2 plus 2 radical 3 minus radical 6 minus 2. And none of these now are like terms because this is a radical 2, this is a radical 3, this is a radical 6, and this is an integer. So no like terms in this one, so it just comes out to be 4 terms. In this next example, we have a lot going on. We're going to be foiling, but a lot of these radicals have coefficients on the outside, so we have to take a lot of things into consideration. So we're going to take this 3 radical 5 and distribute them to both of these terms, and then take this 5 radical 10 and distribute them to both of these terms. So when we do that, we'll have 3 radical 5 times the square root of 15, so it'll be 3 times 5 on the inside along with our 15, because they're both radicals, 5 and 15. And then we have 3 radical 5 times 4 radical 10, and this minus is in here, so we'll put minus. And 3 times 4, because those are the coefficients. And on the inside we'll have 5 and 10, so 5 times 10. So moving down, we'll have this 5 radical 10, so 5 radical 10, and then times this 15. And then finally, we'll have the 5 radical 10 and the 4 radical 10. It'll be minus, so 5 times 4, and then 10 times 10. And it looks like we've gone pretty far on our screen. I think I can squeeze it all in there. So in this first one, this 15 will be 3 times 5. So it looks like we're going to have 3 and then radical 3 times 5 times 5 minus 3 times 4 is 12. The 10 will be 2 times 5, so we'll have 2 times 5 times 5. Here we have just a 5 on the outside, and this 10 becomes 2 and 5, and this 15 becomes 3 and 5. Again, just doing the prime factorization of all those. So it looks like I'm going to have 2, 3, 5, 5, 2 times 3 times 5 times 5. And this last guy will be minus 20, and 10 and 10 will be 2 times 2 times 5 times 5, because each one of these will be 2 and 5. Okay, so in this first one, we can pair up these 5's. Second one, pair up the 5's. Third one, pair up the 5's. And the last one, we can pair up the 2's and pair up the 5's. So we'll take it from the beginning. The 5's come out and go with this 3. So 3 times 5 times the square root of just 3, because that's left over. The next one, so minus 12 times the 5 that comes out, times the square root of 2, because this 2 is left alone. Here we have this 5 come out, so we plus 5 times 5. And we have a 2 and a 3 that don't pair up, so we'll put those together and make that a 6. And then minus 20, and these pair of 2's and this pair of 5's come out, so times 2 times 5. Okay, so here we go. We have 15 times the square root of 3 minus 60 times the square root of 2 plus 25 times the square root of 6 minus 20 times 2 is 40, and then 40 times 5 will be 200. It looks like no like terms here, because we have a square root of 3, a square root of 2, a square root of 6, and an integer. So it looks like this will be our answer. So there's a lot going on with that problem. In this final example, we're going to have the quantity 5 minus radical 2 times the quantity 5 plus radical 2. And it looks like what we have here is the factoring of the difference of squares, because we have 5 and 5 here, and then radical 2 and radical 2 here, and the signs are opposite. One's minus and one's plus. So that's going to be a difference of squares, which is nice because whenever we multiply and do the inside terms and the outside terms, they're going to be negative 5 radical 2 and positive 5 radical 2. So we know those middle terms are going to cancel. So really the only thing that we care about are the first terms, 5 times 5, and the last terms, which will be minus radical 2 times radical 2. So in this case, we can say 5 times 5 is 25, minus, and then we have 2 times 2 on the inside together, which will pair up and come out. So it looks like it's going to be 25 minus 2, which will end up being just 23. So this is nice because all of our radicals went away and we were left just with an integer.